0 and liftoff.
We are wrapping up the last of the vehicle test and get ready to make it a real spacecraft here before too long. It's going to be a big push, but that's kind of how the end game goes. We try to get things ready, and every last thing has to be done and done right. It takes a lot of time and a lot of effort to do it.
We have a lot of work to do in the next 2 months because although the vehicle's in Florida and we've stacked it together just in the last couple of days, the rover's got its rocket jetpack on it, and the jetpack and the rover together have been put in the back shell of the vehicle, and right now we're putting the cruise stage on top. In some sense, that process is actually pretty straightforward. The challenge we have here in Pasadena is finishing up all our testing. All of our testing in our test bed and on the equipment, and going through and looking all the problems we had in our test program, make sure that all the problems we found were all solved and that we know what we're going to do and how we're going to fly it.
3, 2, 1, fire. Everyone stand by. Rover deck.
Testing is a lot like renovating your house. You can enumerate some very large, obvious things to do, and then when you do them, it becomes clear that there are some secondary things to do. And then when you do those, you discover third order, fourth order, ad infinitum. We require our system to be able to be robust, to survive a number of different kinds of faults, both internal faults, things breaking on the spacecraft, or loss of sun data coming into the sun sensor, a variety of unfortunate circumstances we try to make our design robust to.
Not only have we driven the rover, we've removed its arm, put it all through its paces, but it's been in a thermal vacuum chamber and kept very cold. Parts of it have been in a centrifuge. We've done drop tests, pull tests, drive tests, load tests, stress tests. It's just an amazing amount of testing this vehicle has gone through. We've done shorting tests. We've taken the vehicle and shorted electronics. We've looked to see that the radios all work together and that the rover doesn't interact with itself in bad ways. We've tried every way of operating the vehicle using the software, literally thousands and thousands of hours of software testing. It's been just an amazing several years, really, of constant testing and development, finding problems, fixing those problems, and going on to the next problem.
The system is sufficiently complex that anything you change has to be done with great care and caution, and then tested thoroughly because of the potential for side effects, unintended consequences of the fix. The first rule of engineering this late in the game is do no harm.
This is a very, very complicated beast. This is by far the most complex thing we've ever built. It's almost hard to imagine how complex it is. And in fact, if you get close up to the vehicle, you can see the richness of detail. And in fact, this vehicle almost has fractal-like complexity. The more you look at it, the more details that you uncover. And yet to make sure, when you're building this thing and testing it and designing it, that those interactions are well understood and that there is nothing about the system that will interfere with itself. And this has been a real challenge that we've had. And so every minute of the time we've had, we've been using that time with incredible intensity. So hopefully we'll take a big breath in mid-November before we launch and be able to relax and let this vehicle off the ground and finally say goodbye. I think she's ready to go.
Before Curiosity can explore Mars, it's got to get there first. The last stage of the launch vehicle gives the spacecraft a final push and spins it up for our 8.5-month cruise to the Red Planet. Ten minutes before hitting the atmosphere, the cruise stage separates and final preparations for entry begin. Hitting the atmosphere at about 13,000 miles per hour, the spacecraft begins to slow down. While slowing down, the spacecraft uses its thrusters to help steer toward the landing target. We throw off weights to rebalance the spacecraft so that it's lined up for parachute deploy. After slowing to about Mach 2, or about 1,000 miles per hour, we deploy the parachute to slow down even further. Once we're below the speed as found, the heat shield separates and the spacecraft looks for the ground with the landing radar. Once we reach an altitude of about 1 mile, the spacecraft drops out of the back shell at about 200 miles an hour. It then fires up the landing engines to slow it down even further. Once we've descended to about 60 feet above the ground and are going only about 2 miles per hour, the rover separates from the descent stage. As the rover is lowered, the wheels deploy in preparation for landing. Once the rover is on the ground and touchdown has been detected, the descent stage cuts the rover loose. It flies away, leaving Curiosity safe on the surface of Mars. One of the first things Curiosity does after landing is to deploy the mast, which supports many cameras and instruments. Curiosity shoots a laser at an interesting target. This helps us quickly understand the kind and composition of that target from a distance of up to 30 feet. If the target's worth a closer look, Curiosity can drive up and inspect it with the instruments and tools at the end of its arm. The drill on the arm allows us to grab some of that rock and deliver it to the laboratory instruments inside the body of the rover. Those instruments can tell us even more about the mineral composition, getting us closer to understanding whether life could have existed on Mars. Curiosity will be exploring the Red Planet for at least 2 Earth years, and there's no telling what we will discover.